Okay, so we're looking at our first guided practice here. We are given our function differentiated and we want to find out what f of x is when it goes through this point here. So we're going to first of all integrate f dash of x. Now, similar to the examples from that last lesson we did before Easter, we need to simplify this function first. So, if we let f dash of x equal x squared minus 2 over root x, using our laws of indices, we can write root x as x to the power of a half. Now we've got a fraction with a denominator of x to the power of a half, which we can split up into two separate fractions. So that is equal to x squared over x to the power of a half, subtract 2 over x to the power of a half. I'm going to now use my laws of indices again to simplify this further. So when we've got x to the power of 2 divided by x to the power of a half, we've got x to the power of 2 subtract a half. Here we've got 2 lots of x to the power of a negative half. So 2 subtract a half, that is 3 over 2, and we've got subtracting 2x to the power of negative 1 half. I'm now going to integrate this function of x here. So f of x, that is equal to the integral of this function. So I'm going to integrate each term separately. I'm going to add 1 to the power and then divide it by that power. So 3 halves plus 1, that is 5 halves. And then I'm going to divide this term by that power. So that becomes 2/5 x to the power of 5 halves. I'm now going to add 1 to the power here. So I know I've got x to the power of a half minus a half, add 1, that's 1 half. And I'm now going to divide 2 by a half, which is 4. And I'm always adding that constant at the end. Now we were told that our curve goes through this point here. So we know when x equals 4, y equals 5. We've just integrated our function to find that the curve is equal to 2/5 x to the power of 5 over 2, subtract 4x to the power of a half, plus that constant. Using the information we are given here, that coordinate, we can now find a value for that constant. So I'm going to substitute in x equals 4 and substitute in y equals 5. So I get 5 equals 2/5 4 to the power of 5 over 2, subtract 4 times 4 to the power of a half, plus c. Now using my calculator, I know that 2/5 times by 4 to the power of 5 over 2, that is 64 over 5. 4 times 4 to the power of a half is 8, and we're adding c. I've now got an equation with one unknown variable, which is c, so I'm going to rearrange it and solve it in terms of c. So first of all, 64 over 5 subtract 8, that is equal to 24 over 5. So c must be equal to 5 subtract 24 over 5, which is equal to 1/5. So I now have my value for c. I'm going to substitute that into my equation of the curve, and my answer is that y equals 2/5 x to the power of 5 over 2, subtract 4x to the power over half plus 1